going to get started now. My name's Matthew Jarrett, and this is Alan Keir. We've also got Peter Ferry and Iona Murray at the back, who are all from Wallet Services. Today, what we're going to try and do is give you an introduction to blockchain. So I think some of you have a bit of experience already. Apologies if this is basic, but we're going to start at pretty much ground zero to try and give everyone enough information to have a look at our platform. And we'll give you a little use case to go along with that to kind of explain it a bit better. And then we're going to do a quick start code along. So we've got this quick start template that hopefully, fingers crossed, will get you all up and running on your own machines. And then we've got some pizza coming at some point, and have a bit of time just to hack away, and we can talk to you individually and see what you're doing, and maybe see where we can take things if you want to take our platform home and play with it, basically. So let's not delay anymore. We'll just do a quick introduction to blockchain. So for those of you who don't know, blockchain came out of the Bitcoin project. So Bitcoin, again, is you've probably heard of it, but it's a digital currency, basically. And blockchain is one of the technologies which backs that and makes it work. It's not the only part of Bitcoin, but it's a very important fundamental part of it. But yeah, Bitcoin is a decentralized ledger, so that means it's got no central point of control. That's a very important thing of what Bitcoin tried to achieve. There's no bank for Bitcoin. Everyone's an equal, and it's a ledger, so it just holds a record of transactions, who gave what to who, essentially. So before we start, anyone willing to take a punt at what they think blockchain is? Anyone got experience? Yeah? Shout out. I mean, you might know more than me.
Well, I suppose each block is just the miners sort of finding or solving the algorithm that they're trying to solve. And you have all the transactions that take place during that window, which are kind of written in stone once that block is found. And then the miners all kind of have consensus, agree on that, and then everybody moves on to the next block.
Yeah.
The block.
Yeah. So blockchain, that's mining and things like that are not actually part of blockchain itself. Blockchain is very basic. Blockchain is just a way of storing data. It's just a layer, but that's all useful stuff, part of the Bitcoin protocol. But it's basically just a tamper-resistant way of storing data. So the idea is, like you say, the mining in Bitcoin is the way that this is done. When things are added to the blockchain, they can't be changed. And if they are changed, then it's easily detected by anyone checking the blockchain. So that's basically what blockchain is at its most basic level. Blockchain is just a data store, but as I mentioned, Bitcoin has another few things about it which are important. And one is that it's a peer-to-peer network. So again, some of you might know, but what's a peer-to-peer network? What's the important properties of a peer-to-peer network? Anyone willing to volunteer?
Person sharing of data.
Yeah, so a peer-to-peer network is when you've got a network of computers, let's say, and there's no central point of control. Everyone's an equal in a peer-to-peer network. So if you think of the World Wide Web, the way things work is you've got servers, you've got clients, and clients go, I want this page, the server returns it back. So there's a hierarchy there, whereas in a peer-to-peer network, everyone's an equal, and there's no central point of control. So let's pretend this is a peer-to-peer network. We've got lots of computers here, and they're all, it's quite rigid how they're connected, but in a peer-to-peer network, anyone can connect to anyone at any point in time. And that's what Bitcoin is built on. And we call each one of these computers in a peer-to-peer network a node. And in the Bitcoin peer-to-peer network, that's a node, everyone stores their own copy of the blockchain. So here we've got the Bitcoin blockchain is stored at every node, and that is the entire blockchain is stored at every node. And they have they interact with each other to say, I've got this new transaction, or they ask for other nodes to tell them what new transactions they have, but ultimately they act independently and they make their own decisions about what the blockchain looks like at any point in time. Can anyone spot a problem with this? It's maybe a bit obvious if you're involved in blockchain, but if you're all making your own decisions, then what's the problem you've got to solve?
How does everyone else have the information you have?
Yeah, so how do you agree on what the truth is at any point in time? And the way that this is achieved in Bitcoin and other blockchain networks is this idea of a consensus mechanism. And the consensus mechanism is basically a special, cleverly thought out set of rules that when all the nodes independently follow those rules, they magically end up at the same answer, unless they're trying to do something nefarious. But if you've got more than half of the nodes following these rules, then you end up with the same answer, and consensus is reached. But consensus is, so in Bitcoin, it's you might have heard of proof of work. That's the way it works in Bitcoin, but it's quite a complex subject, and there's lots of different consensus mechanisms. So we're not going to talk about that today. We're going to kind of focus on what the blockchain is in itself, because that's where we're kind of, that's the space we're working in with the wallet services platform. So to understand blockchain, there's one kind of key idea that we have to get our head around. Some of you might have heard of it before, but it's a cryptographic hash. So the idea with a cryptographic hash is you put in some data, that's any data, and you get out what's called a digest. And a digest is a fixed length string, let's call it. And there's two important properties about this. One is that given that digest and full knowledge of this hash function and how it works, you can't reverse engineer that. You can't take this digest and go, oh, I can figure out what the input is. That's next to impossible. And the other important property of a hash function is that given different input data, you'll always get the same but different output data. So if you put in strawberries, you'll get out a hash. If you put in bananas, you'll get a different hash. If you put bananas again, you'll see same different hash. So it's like a thumbprint of that data. So you can use it to identify that data and say that was the data that produced that hash. So if we look at a blockchain, the Bitcoin blockchain, for instance, is made up of transactions, and we'll look at them a bit closely in a minute, but basically they're arranged in blocks. And the way a hash is used in the blockchain network is when a block is added to the blockchain, this block is hashed, so that's passed through the hashing function, and then that hash is included in the next block. And that way, you can tell if you hash that block and you get that number, everything's okay. But if you hash that block and you get a different number, then something's been changed and you know you've got errors. And because this is linked, you can see all the way back down to the beginning of the chain, anyone can quite easily check the entire history of the blockchain and figure out if it's the right state for the system or if someone's been tampering with it.
So you input 130 and get back the hash and go for 129?
Yeah, so all the data in this block, it's a bit more complex, but you can conceptually, you take that entire block, all the data that's in there, you pass it through the hash function and you get this digest out, and that digest is included in the next block. Does that make sense? Yeah. Yeah, so that's a blockchain. And now let's look at a transaction. So that blockchain is made up of lots of transactions, and fundamentally a transaction has four, let's call them properties, things you can determine from that transaction. The first is it's got an owner, so that's the person who owns some Bitcoin in the Bitcoin network. You've got an amount, which is how many Bitcoin that they're sending, and you've got the recipient, which is the person they're sending the Bitcoin to. And there's this fourth thing in the Bitcoin network, which is some arbitrary data, and that's it's not kind of it's kind of used and abused in the Bitcoin network, but it's not. It's a bit of a contentious subject actually. So that just bear that in mind. There's four properties, and we'll be looking at data. Data is quite important in the wallet services platform. We're just going to take a little detour to look at how transactions are sent on the Bitcoin network. You talk about sending someone Bitcoin, but it's not. That's kind of the wrong word to use. You don't actually send Bitcoin on the Bitcoin network. What happens is you record in the network that you're transferring ownership from one person to another. So you record that in the blockchain. There's no kind of sending this data off to someone else. It's just creating a new transaction. And the way that's done is that the person sending the Bitcoin uses their private key to digitally sign that transaction and say, right, I'm now transferring ownership to someone else. And then anyone can come along and use their public key to verify that it was in fact that person that released those funds, if you like. So that means that this private and public key are mathematically tied together in a very special way that allows this verification process, but you can't take this public key and figure out what the private key is, because obviously if you do that, then you've got control of their funds. You can sign their transactions, yeah?
Would you say that this is how Bitcoin creates a transparent kind of network, so that everyone can know
Yeah.
If people want to find out if something's happened, if something's been sold or something's been transferred, they can tell.
Yeah, so the Bitcoin is a public blockchain, which means that anyone can access it and anyone can look at the contents of the transactions and see who's given what.
Your peers are your enforcement?
Kind of like notaries, really. So I think the biggest thing in Bitcoin was they found a way that people could prove that they've transferred some currency out in the open. So you don't need, say, a bank or something to carefully watch. You can do this out in the open, and the reason you use a public and private key is it's just a mechanism where you can do this in a way that, you know, it's undeniable proof that it's happened.
Yeah, while still being safe to the people who are doing the transaction.
Yeah, because remember, on these types of networks, what they don't want to happen is if you send some currency to somebody, you don't take it back later on and try and send it to somebody else. So it's all about preventing those double spends, basically. So a combination of that and the consensus algorithms, you know, sets a framework for that.
Yep. Any other questions at this point? So with that in mind, that's basically how transactions are signed. If we go back to this idea of a transaction, we can look at what we've done differently. I mentioned it's the data in the transaction which we pay an emphasis on. So in the Bitcoin network, I think it's limited to 40 bytes of data, so it's almost nothing. Sorry? 80. Is it though? There was a proposal for yeah. Anyway, yeah. So it's nothing almost in computer. I mean, you talk about gigabytes and hard drives these days. It's almost nothing. You can't store a document or an image in there. But with our platform, one of the key things we've done is we've created our own flavor of blockchain. So it's heavily based on the Bitcoin blockchain because that's the original and it's probably the most proven out example use case of blockchain. So we've tried to stick to Bitcoin, but we've made this fundamental change that allows 4 megabytes of data to be included in a transaction. So that means you can put a document, a photo, a video, anything you want basically inside a transaction. And that's where our platform provides a bit of utility with blockchains. And if you imagine our blockchain, this is what it might look like. You've got transactions all inside their blocks. It's probably more transactions than that, but that's the idea. And we've got this other idea of saying, well, you've got the whole blockchain there, but you've also got a subset of transactions within that. There's like a subchain. It's like a conversation that's happened through the blockchain, and we've given that a name, secure flow. And so the idea is that those particular transactions or those particular transactions can be used to represent like a workflow. So if you've got like a licensing process where there's many parties involved and they've each got to do a certain thing, you might apply for the license, you fill in data and send that to the police. The police might check that data and check the forms filled in correctly, stamp it with their Boolean, yes, no, is this correct? And then might send it on to someone else who'll do a background check. Then you might, that's the idea, use a secure flow for that. So at each step, someone's contributing the data and it's being irrevocably stamped into the blockchain, and that information is there for forever and is verifiable by lots of people.
I'll just add in, it's encrypted. So this isn't people filling out forms and it going in plain text on a blockchain. It gets encrypted point to point on this process. Yeah,
so we'll just go into a bit more detail of what a transaction, a secure flow on our blockchain might look like. So you've got transaction 0. When you want to start a new transaction, secure flow, you request one from the system, and the system sends you this initial transaction, and you can specify some initial data that goes in that transaction. You might use like a title for the secure flow. You might call it my secure flow. So you've got this secure flow with the title that's in that first transaction you can reference. And then let's say that goes to user 1. User 1 would then create another transaction, add some more data to that, whatever they want, and they'd send that on to user 2. And then it continues for as long as you want. User 2 can add some more data and send it on to another user, back to user 1, send it on to whoever. And that's basically how it works. So if we take a concrete example of that, back to the license. Sorry, no, we'll take a different example. Imagine you've got two people, Alison and Will, let's call them. And Alison and Will want to agree a contract. So they've got this set of terms, and they want to agree and record the fact that they've agreed to these set of terms. So Alison would request an initial secure flow transaction from the system, and she might give it a title as the initial data saying agreement with Will. And then Alison would create a second transaction, and she'd bundle in that contract terms, so that could be JSON or whatever format of data inside that transaction, and she would send it off to Will. Will would review that, and then he would create a third transaction that would indicate he's agreed with those terms, and he would send that back to Alison. And then at that point, this agreement, the initial terms and Will's confirmation of agreement is written into the blockchain and is independently verifiable by Alison or Will. So it's obviously got a lot of utility.
Just a quick
Yeah.
question. So would each coin have that space? Not just the entire transaction of each coin?
So the coin is kind of used as a carrier. It's got no value in our blockchain. It's just, like I said, we're trying to stick to the mechanics of the Bitcoin network as closely as possible. But that coin is given to the first person. That allows them to spend it. And when they spend it, they send it to the next person. And when they spend it, they attach that data to that transaction. And the coin kind of follows along. Is that, Alan, do you want to kind of explain that differently?
Yeah,
or?
so it's a security mechanism, really. So there's kind of real two steps to a workflow. The first one is when you initially create a transaction. That goes out in clear text, and it's almost like a schema. So you say, right, this is a contract we're entering in. Everybody in the blockchain can see what we're doing. And then the remaining transactions are encrypted blobs of data that kind of go with it. And the coin is just a mechanism to make sure people don't kind of abuse the network, and also a good way to trace back through workflows. So at any point, given you're working on the history of a single coin, you can navigate forwards or backwards to see the different points in the workflow. Does that answer it?
So where do you get the coins from? Like, how do you?
The system generates it and sends it to you. Yeah.
What's the rationale for keeping a coin? Why not like key or like root?
Well, it's Bitcoin terminology.
Well,
Yeah.
so the thing is, when you create a blockchain, if you just go off and engineer one yourself, nobody's going to use it because you haven't proved the security. However, if we can take Bitcoin, which has got a market cap of, I don't know, it's something
50
like
billion,
yeah.
almost, yeah.
No, it's
40, is it? 80 billion, is it?
Or
Oh.
something like that.
45 billion, 46 billion.
No.
It's tens of billions.
But the fact is, nobody's in control of the Bitcoin network. It governs itself. So if we were to just take the protocol rules in Bitcoin, slightly re-engineer it, but not break any of the rules, i.e. any transaction we create in the system would be perfectly valid on the Bitcoin network, then that's when you start to get something more interesting. The other reason that the system generates the first transaction is if you create your own say, new currency, if you don't have enough people to mine it or to be involved in the consensus, then it will not protect itself. If somebody wants to subvert your system, they just need to create a botnet, more power than say half your network. So what we do is we do a semi-public, private, well, we call it a hybrid network, where anybody can connect to the network, send transactions, but we create a few special nodes that know how to mine and create these ones, and we leave those to initialize the transaction so that others can continue and apply those workflows, and they can also customize the particular consensus that they use, but that's in a bit more detail than we're going to present today.
Is there another question at the back?
Yeah, so basically, like when you have those secure chain, so that
Yeah.
it gets mapped back to the first block where the transaction was initiated, or it just propagates through blocks as they get added on.
Sorry, I don't follow the question.
In this slide, you have like 3 blocks,
Yeah.
and the transaction was initiated in a block 1 to 7, and then does it get linked back to this block as more data gets added in by
Yeah.
parties?
So,
Or it like propagates through?
so like in a Bitcoin network, you can look at a transaction where someone received some money, some Bitcoin, and you can trace it back to the genesis. Like Bitcoin are created in a called the Coinbase. So when a block is mined, someone gets some Bitcoin for doing that. But you can trace all Bitcoin back to the Coinbase where they were created. So it's a similar thing here, where you can trace all this back to here, and they're linked through the blockchain as a kind of sub-entity.
Someone initiated a transaction, and some other user or some other party in some other block in the future added some data to it.
Yeah.
Then it's basically like a coin with additional data.
Exactly. Yeah. It's a transaction that has one coin and some arbitrary data, and that data is.
Just a comment to what you said. So basically, your system is in a way decentralized because you have those nodes which essentially take care of mining.
It's more like a decentralized network with proof of authority. So anybody can spin up a node and interact with your network. They can also add transactions to the memory pool, and the memory pool just are transactions. They just get propagated throughout the network. Eventually, one of the authoritative miners will pick that up and mine a block for them. So we use proof of authority just to make sure the network's secure. Because obviously, if we grew to the size of Bitcoin, we wouldn't need them, and we could just have public consensus. But realistically, the kind of, we're creating a platform so you guys can go off and build your own networks. We don't expect those to be large, so we give you the ability to run your own miners, so you can define what's allowed and what isn't allowed.
Yeah. The way I look at it is that although you've got the central a wee bit have some special abilities, anyone can look at the network and check that all the rules have been followed. And okay, some people can create the blocks, but anyone can check that they've done the right job, for instance. Yeah.
Exactly.
Yeah.
Are there, are there only two classes of nodes? So you have the authority node and then the regular node?
Well, right now, yes. But I think that's actually the harder way to do it, because what you have to have is essentially public consensus between authoritative nodes. Having different levels, say one that's in charge of who else can mine, is an easier route. So right now we're set up that way, but we're planning to customize it, so we don't want to be too opinionated in the way that you set them up. Like, some people just need private networks, so everybody's a miner. If you trust everybody, that's fine. But some people want to set up a system where everybody can check that the miners are doing the right thing, but the mine is just protected. So we're trying to keep a clean canvas, so that our developers can decide how best to structure their blockchains.
Okay. Just one more question. Can a transaction only happen between one person to another? Can it be one group to another?
Yeah, so we have Multisig in the platform. I mean, so our platform's about 9 months old, and we built it out. We can give you a demo today. There's still a lot to go on. We handle a lot of the security for you, but we do implement Multisig. We're going to expand upon it. So yes, but maybe not right now. But hopefully pretty soon. Another idea is we're dealing with just a single coin, but there's nothing to stop you having, say, 2 coins, so that different people can do things at the same time. And perhaps a consensus protocol would be, workflow is only complete when the coins converge. But I think we'd really like you guys to figure out how that you want it, and we just want to give you tools to, to do your own thing. So.
For those of you who, the term multisig basically means that when explained, someone signs a transaction to say, I release these funds. Multisig means that multiple people have to sign that transaction to release the funds. Yeah.
Matt, before moving on from that slide.
Which one, sorry?
The red.
Oh, right. Go all the way back.
Yeah, so this is the sub flow.
Secure flow, yeah.
Secure flow, okay. So in practice, would those blocks be spread far out?
Yeah, potentially they could be anywhere on the blockchain, yeah.
So the first one is like set. Is this a smart contract?
Yeah, you could think of it like that. So the very first transaction contains the plain text. That's a contract that everybody's following, and the remainder of it are people's contributions to what they've got to do. So we could, and we are, implementing this as smart contracts. It's just with a lot of systems like Hyperledger, you cannot have open networks. So you know, in say Hyperledger, you can have secure channels. So you can have an open Hyperledger, but everybody's got to register with a key, which means people can't just come along and join your network. So that's you know why we're forging ahead with this one. But we are planning on using both and allowing both to interact between them.
What do you mean by both? Sorry.
So you could set up a Hyperledger blockchain or group of blockchains for channels, and you could use a first generation blockchain like this one to provide an open network, and set up the right way, they could exchange. So provided, say a node has sight of both blockchains, then if you like, they can become oracles, and data, you know, contracts can be consumed that uses a bit of both, you know, or, if you get me.
More questions? Nope. So just move back. So that's kind of the kind of blockchain we're working with. Just going to quickly go over the kind of overall architecture of our platform, kind of the moving parts and what you'll be creating in a minute when we get you up and running. So we've basically got the wallet services blockchain service, and this is our clever bit that does all the blockchain transactions. And then we've got our API tools, which is the kind of library of software that you use and interact with directly. So when you sign up for wallet services, we create a node for you that initiates your blockchains. You've got a blockchain as soon as you've got one node. We look after that first node for you, and we expose that to the outside world via a REST API. And you don't actually have to talk with this API directly. That's what the wallet services tools does for you. And the wallet services tools present you with four easy to use methods to interact with your blockchain, which I'll go over in a minute. And the other part of our platform is we've got this secure token server. So secure token server, for those of you who are not familiar, is a way of authenticating users. So proving people log in. So when you log in, you enter your credentials. The secure token server manages that. And then we've got this package called OIDC client, which is actually a third-party bit of software, and that interacts with the STS for you, so you don't have to do all the authentication stuff. You just say, is someone authenticated and who are they? So we've written this quick start template, which is what we'll be using today, that kind of wraps up this authentication and API tools bit for you. And there's two parts to that. It's a modern, I don't know if it is modern anymore, you've got an API and a client, basically. And we've chosen to start with .NET Core as our API. And for today, we're using a plain HTML and JavaScript client because we thought that'd be most accessible. If we do Angular, some of you might not know Angular. If we do React, some of you might not know React. So it's just plain JavaScript, HTML. And in that template, you obviously then plug in your own custom code in the API and in the browser client to do create the project, do the functionality that you want to do with blockchain. Any questions on that before we move on? That's the kind of overall picture of what we'll be doing today.
Is that OIDC client, is that open source?
Yeah, it's on NPM. It's kind of a standard for OpenID Connect. It interacts this. We run Identity Server as our authentication, and it does that piece quite nicely. Just plug in the credentials and away it goes. So that's the overall picture of what we'll be using today. So I mentioned there's four methods that the API tools exposes to you. So this just user authentication. You can say who's logged in, and this bit actually is where you speak to say, I want to interact with this blockchain that you've created for me. And the four methods we've got are get address. I don't think we actually mentioned this in any detail, but on a blockchain network like Bitcoin, you've got this concept of an address, which is somewhere you send bit, well, as we said, it's not sending, but it represents the party that you're giving the Bitcoin to. You're sending the transaction to. So we've got a function to get an address for a user. We've got a function to get your secure flows. So secure flows is a group of transactions, and call that method, you get all the steps back, so you can see who's been sent what for in the context of a user. So it would be the secure flows for a user. And then we've got a function to create a new secure flow. So when Alice went, I want to create this new secure flow, or the application would call that method on her behalf to create this initial transaction. And the final one we've got is continue a secure flow. So if you've got the second transaction, Alice wanted to put the terms in and send them to Will, she would continue the secure flow, passing in that piece of data and Will's address to do that. So that's the platform. Next, we're going to get you set up and try and get the platform running on your computers.